Okay, matrices. This table here shows top scores for girls in barrel racing at the 2004 National High School Rodeo Finals. The data can be presented in a table or spreadsheet as rows and columns of numbers. You can also use a matrix to show the data. And a matrix is a rectangular array of numbers enclosed in brackets. So here we have the table is here. And we've taken that table and we've converted it here to matrix. Okay. Matrix has, or this matrix, which is matrix A, it's always called by a capital letter, has 2 rows and 3 columns. So whenever we talk about the dimensions of a matrix, we mention the rows first and then the columns. So we would say this was a 2 by 3 matrix. Right, so a lot of times they use the letters M and N, so an M by N matrix. So how many rows there are by however many columns there are. The address, which is each value in the matrix is called an entry. The address of an entry is its location in the matrix. So here we have, they call this address, it's A subscript then 21. Lowercase a subscript 21. The first number represents the row number. The second number is the column number. So that means that we're working with matrix A, so we're using a lowercase letter to represent the address. And 2 means it's in row 2, and the 1 means it's in column 1 then. Okay. So where then this one here, 17.318 would be, okay, A sub 13. It's row 1, column number 3. All right, and today what we're going to look at is displaying the data in the matrix form. And then we're going to look at basically just kind of adding and subtracting some matrices. So the thing is that if it's a matrix, you don't use commas, okay, which some people tend to want to use commas. Don't use commas. And it's enclosed in brackets, right? Not braces or parentheses, but brackets. All right, so here's a set of data. This is the prices for different sandwiches are presented below. Now, we just put the numbers in the data. We don't, or in the matrix, we don't care about the labels, all right? So like, for instance, this says it's the column that says 6 inches. All we're going to do is put those numbers in the matrix. And the column that's 9 inches, we'll just put those numbers in the matrix. So our matrix that would represent this data would look like this then. So it basically looks just like the data. All we're doing is what? Okay. Getting rid of the names and removing all the lines, right? Okay. So what are the dimensions of this matrix then? At least what would be the dimensions? Okay. The dimensions are how many rows by how many columns. So how many rows are there? 3?
I don't know, like with this columns up and down, or is
Yep.
rows up?
Columns are up and down, rows go across.
Or right?
We're looking at the matrix here, Elise. Okay, not the set of data. Looking at the matrix. How many rows are there?
2 or 3. I don't know, don't ask me. 3.
All right, Mr. Franklin, would you help her out? How many, what are the dimensions? The dimensions, so we talked about this one right here. This one is 2 by 3. Okay, this matrix is a 2 by 3 matrix because there are 2 rows and 3 columns. Okay. We're just talking about the matrix here.
3 by 2.
Okay. All right. There are 1, 2, 3 rows and 2 columns. All right. So it's a 3 by 2. Okay.
Hi, Cameron. I was
Right.
lazy.
So when we're doing the dimensions or the address, we're looking at the matrix, not the data in the table. Okay? We don't pay attention to, we don't care about what the labels are. We only care about the numbers that go in the matrix. Okay? All right, the entry at P32. All right, and they want to know what does it represent. So we will have to reflect back there. All right, Carolyn, what's the entry at P sub 32?
Isn't it
It is 525. What does that represent?
like 9 inches?
Okay, how much it costs for a 9-inch tuna sandwich? Good. Okay. All right, so the 32 means I'm going to go down to row 3 and go over to column 2. And I have 5.25, and that means I have a 9-inch sandwich or 9-inch turkey tuna sandwich. There we go, 9-inch tuna sandwich. Okay. So what's the address for the entry that's 5.95? Jordan?
P1 12.
Okay, P sub 12. All right, because we're in row 1, column 2. All right, let's undo that. There we go. All right. The entry at 5.95 is at P sub 12. All right, it's row 1, column 2 is where we're going to find 595. Okay. So the dimensions are how many rows there are by how many columns. Okay, so this one is a 3 by 2. The entry at P sub 32 means I'm going to go to row 3, entry 2, all right, and figure out where that one is. Okay. And if we're looking for the address is the row number by the column number. Okay. So do those same 3 questions basically for this one. Okay, adding and subtracting matrices. Okay. When you're adding and subtracting matrices, one thing must be true. The matrices have to be the same size. Okay? If they're different sizes, you can't add them and subtract them. Okay? For one. And number 2 is when you're adding and subtracting, you just add the corresponding cells or entries. Okay? So for instance, if I'm going to add these 2 matrices together here, the matrix 1, 2, and 5, 10, first of all, I have to make sure they're the same size, and these are both 1 by 2. And then I would just add the 1 and the 5 and the 2 and the 10. And that would be our answer. Okay? You're just adding corresponding entries together. All right? So here we have these 4 different matrices. And we're going to do some adding and subtracting if possible, because sometimes we can't. So let me ask you this. Zach, what are 2 matrices that we cannot add together? W and X, okay? All right, we cannot add them together. So the first thing we should do is write down what their size is. So W is a 2 by 2. X is a 2 by 3. Y is a 2 by 2. And Z is a 2 by 3. So we can combine W and Y and X and Z, okay, because they're the same size. Right? So here they want us to add W plus Y. So I look at the sizes, the dimensions of W and Y, and they're the same. So I can add them. So all we do then is add the corresponding entries. So I'm going to add 3 plus 1, okay, because they both represent entry 1, 1. Negative 2 and 4, because they're both in entry 1, 2. 1 plus negative 2, and 0 plus 3. So we're just combining the ones that are in the corresponding entries, or they have the same address, you could say, in the two matrices. So I would have a new matrix, which is 4, 2, negative 1, and 3. Okay. Now, the thing is make sure you use brackets then, and make sure you use spacing, good spacing, so it doesn't look like they're right next to each other, right? Because you don't want this to look like it's negative 13. Letter B. We're going to subtract x and z. Now, what are we supposed to do when we're subtracting? Normally, when we have subtraction, what do we do? We minus, but like if I had something that had a minus sign and parentheses, what would we do? Okay. Right. Okay, we distribute the negative, right? Okay. So one of the things you might want to do is distribute the negative, and you can do that. Okay. Or you can just do your normal think about subtracting. You can write out the actual work. So in this case, then, I look at x and z, and they are the same size. They're both 2 by 3s, so I can subtract them. So we subtract the corresponding entries. 4 minus 2, 7 minus negative 2, and 2 minus 3. There's our row 1. In row 2, 5 minus 1, 1 minus 0, and negative 1 minus 4. So we can write it out, and for some of you, it might be a good idea to write it out. For others, you might not necessarily need to. It's up to you to do that. Right? So then we just do our subtraction, and we would get 4 minus 2 is 2, 7 plus 2 is 9, then negative 1, 4, 1, and negative 5. And letter C, they want us to add x and y. Okay, can I add x and y? No. Okay, they have different dimensions, so we can't. Right, so that's not possible. All you have to say is it's impossible because they're different sizes. You would need to tell me why. You can't just say no. You need to say these are different sizes, so they can't. Yep. Yep. Okay. So let's do one of these. All right. Let's do one we can do. So which ones can I combine? Can I do A? B and D, can I add them together? Okay, yes we can. How about B? Can we do B minus A? No. Okay, because they're different. And what about C? Can we do D minus B? Okay, so I want you to do C. Do this one. Okay, we know that multiplication is repeated addition, right? Same is true for matrices. Okay? So if I was to do E plus E, that'd be the same as 2 times whatever's in matrix E. All right, so we're going to talk about scalar multiplication, or multiplying by a scalar, or scalar product is another way they pronounce it. And all that means is we're going to take whatever number's on the outside and then multiply it by each number on the inside. So any scalar multiplication, they show us an example here, that if I have 2 times this matrix, then all I'm going to do is multiply each entry in that matrix times 2. And we're actually going to take a little story problem and look at this one with. Okay? Here we have shirt prices, small, medium, large, extra large, and t-shirts and sweatshirts. They want us to use a scalar product to find the prices if a 10% discount is applied to the prices above. Okay. So what happens if I have a 10% discount? Oh, Jesse? Okay, now Mr. Franklin says multiply by 0.9. Why? okay, because we're subtracting 10%, right? So if I take 10% away, I have 90% left, right? Okay, so you can do this, you can think of this as two ways. I can think of it as taking 100% of it and subtracting 10%, right? Okay, that would be a 10% discount, wouldn't it? Which that's actually 90%. Right? So we could either find 10% of the number and subtract it from the amount, or an easier way to do it would be to multiply by 0.9. So what I could do is just take this matrix, these numbers in the matrix, and multiply each of them by 0.9. Okay? So that's pretty simple, right? Okay. So what if it's an increase of 20%? Then what am I going to multiply by? Okay, Miss Gibson says 1.2. Okay, so I have 100% plus 20%, right? All right, and so that would be 120%, so we would multiply then by 1.2. Okay. What if it was 220% increase? Okay, all right, so then we'd multiply by 2.2. All right, so you have to think about those things. So all I would have to do here then is multiply each of these numbers by whatever that scalar number is, whether it's 0.9, 1.2, or 2.2, any of those things. Okay? All right, does that make sense?